Your conference is being recorded.
Good afternoon. My name is Bob Fleischman. We're in Washington, D.C., and this is an Energy Bar Association Energy Law Journal lunchtime author talk. I'm editor-in-chief of the Energy Law Journal, and I've been in this role for about 15 years. We've had programs like this since 2013. Usually it's the lead article of the Energy Law Journal, which is published twice a year, and we ask one or more of the authors that participate in the preparation of these articles to come and enlighten us, to make presentations, to take questions, and so forth. Today, the topic is about blockchain and energizing the future. We have folks in the room here in Washington, a number of folks on the phone. This program is going to be recorded. It will be podcast later, and also CLE is available for those who need and want that. It's already been approved for people in Pennsylvania and California. If you need CLE in any other states, you'll have to apply on your own, and after the program, the Energy Bar Association folks will be sending surveys that will have certificates of attendance and information about getting CLE status. There's also a sign-in sheet for people at the office in D.C. here today, and I'm here today at Kirkland and Ellis in Washington. I'm very glad the program is today, not tomorrow, given the anticipated weather and how people in Washington deal with the weather. Today we have 5 speakers. 4 of them are in Washington and 1 on the phone. Their bios, virtually all of their bios, were presented earlier to you all, along with the PowerPoints that will be presented today. Let me just briefly identify who the speakers will be, not in the order in which they'll be speaking. First, we have Buck Enderman, who is a partner in the San Francisco office of K&L Gates. He specializes in environmental and energy regulatory work and, among other things, advises clients, regulators, and working groups on how blockchain and distributed ledger technologies can further carbon compliance and energy trading objectives. Also speaking today from K&L Gates will be Ben Kablum. He's an associate in Washington, and he works on energy and infrastructure projects, and among other things, he's the co-author with people at K&L Gates of the Blockchain Energizer. It's a biweekly publication that highlights emerging issues and the like. And finally, from K&L Gates, we also have Dan Cohn, who was one of the authors of the article as well. This is one of those interesting articles where we have both lawyers as well as technical people and policy people participate in the same article. So today, speaking on the phone, we will have Sam Hartnett. He's with the Energy Web Foundation, and his role there is Research and Market Development Manager. And among other things, he works with utilities, grid operators, research labs, and technology providers to integrate physical grid assets with blockchain-based applications and markets. And last but not least, we have Doug Miller, also with EWF, Energy Web Foundation. He's a manager there, and he advises the technical architecture and features of blockchain, arranges market demonstrations, and engages key market participants supporting the development and deployment of Energy Web Origin, which is a portfolio of blockchain-based open markets, toolkits. That was what I was going to say. So what we're going to have is the first PowerPoint will be presented by Sam and by Doug, and then after that we'll take questions, and then we'll have a presentation by the K&L Gates folks. We'll take questions after that. We will be ending later. We'll see how this goes. So with that, let me turn things to Sam, who is calling in, and we will, Sam, please, when you want to go to the next slide, let us know, and we will advance them here in Washington. Sam?
Great. Well, thank you for the introduction. Hopefully you can hear me all right?
Yes.
All right, great. Well, good afternoon, everyone. My name is Sam Hartnett, and as Bob mentioned, I'm with EWF. Just before we get started, a real quick background on who we are. So Energy Web Foundation is a Swiss-based, not not-for-profit foundation that was co-founded by Rocky Mountain Institute here in the U.S. and a German blockchain company called Grid Singularity back in early 2017. And for those who don't know, RMI is a Colorado-based nonprofit focused on market-based solutions for the clean energy transition. And Grid Singularity is an energy blockchain startup founded by some of the early members of the Ethereum community. And these two organizations got together to really understand how this technology can play a role in the broader energy transition. And so that'll be what I talk about and what Doug will talk about today. And so if we can go to the second slide, which should be the table of contents. Just a quick overview. So we'll start with some context and talk about why we believe we need blockchain technology in the energy sector today, before going into how we at EWF are specifically working in this area. And then I'll turn it over to Doug to take you through some of the more recent developments and what we can expect in terms of applications and use cases this year. And then I'm not quite sure, but I believe we'll do the Q&A collectively at the end, or maybe we'll have time for that. So next slide, please. So before we kind of get into the weeds, I want to just make sure we're all on the same page when we're talking about blockchain. It's a fairly complex topic and one of probably the more discussed and more written about topics in the energy technology space over the last year, but there's a lot of confusion and frankly a lot of hype. So it's helpful to really just think about blockchain in the broader context of the history of computing technologies. So in the beginning, there was hardware, and the early computers were really large, specialized machines that only a few people knew how to operate and were fairly limited in the kinds of tasks that they could perform. But then once software came along, that effectively commoditized hardware in the sense that it didn't necessarily matter which specific machine you were using anymore, as long as that machine could run a particular piece of software to do whatever kind of task. And the other implications of software is that it made it much easier to use computers, opened up the user base to more audiences, and could perform more sophisticated tasks. And then networks came along and the advent of cloud computing. And networks had the impact of getting many machines and thus people to agree on a common set of facts, but they also, in a sense, commoditized software to a degree. The example would be internet browsers or email clients. It doesn't necessarily matter which specific software you're using because you're accessing the same information or service through these networked services. And so we can think about blockchain as a technology that is commoditizing networks, whereas historically we've relied on a particular network provider or an administrator to govern the rules or to maintain the integrity of a network system. Blockchain is a decentralized computing platform, and we'll get into why that's significant over the next few slides. So next slide, please. And this one has an animation that I can't see on my end, but hopefully if you click one more time, folks in the room will see it.
You can see it. It's wonderful.
All right, great. So, I'm sure this is not news to many folks in the room, but the energy transition that we're experiencing is really fundamentally about an evolution in our grid architecture. So we're moving from this world where we rely on relatively few, very large-scale generation facilities to generate and transmit power over long distances to mostly passive consumers out at the grid edge on distribution networks. Next slide, please. And so and there's another animation here. really the fundamental challenge that we're seeing is that we have these markets and control mechanisms and tariff designs and regulations are all built around the central premise of how the grid works and what the architecture is. But now we have more active and dynamic resources both on the supply but also on the demand side that are actively participating both in local markets and in wholesale markets that are physically located at the grid edge, at the distribution grid, that are owned and operated by various entities. They could be the customer themselves and behind-the-meter devices. There are aggregators. There are project developers. There's just a whole new set of stakeholders that weren't really relevant a generation ago. And so we need a new architecture system to help coordinate and integrate more diverse resources with diverse actors that are having physical impacts on the grid as well as monetary and market impacts. Next slide, please. And so when we think about what are some of the characteristics of a revised grid architecture that we need, there are certain attributes that have kind of always been there. For example, we need to ensure regulatory compliance and stability and reliability, but there's new types of requirements that are really emerging as important, such as increasing cybersecurity, being able to coordinate assets or devices that are autonomous in the sense that they aren't necessarily responding to a human operator, but rather a piece of software with some embedded logic in it. The ability to share and secure data from many different types of assets and resources is really important. And so blockchain technology is well suited to achieve a number of these requirements. Next slide, please. And specifically, blockchain is compelling because it effectively commoditizes trust and can automate transactions between these various stakeholders by doing two things. It guarantees agreement, meaning that different parties that are participating in a blockchain platform have one and only one set of facts in front of them, and execution, meaning that a piece of code that represents some business logic or contractual arrangement can be guaranteed to be executed correctly without relying on any third party or intermediary to monitor and ensure the validity of that. And so this is why we're really excited about blockchain. This is why it's been getting so much attention in the media, is that we have this computing technology that can enable many new kinds of transactions that were previously either too costly or too complicated to execute at scale to be performed in a very secure and beneficial way to all these different parties. So next slide, please. And then we can actually go two ahead. So what are we doing at EWF to work in this space? So right now, blockchain really is in its infancy, and the phrase we use all the time is that it's really boutique. We see pilots here and there, we see proof of concepts, but there's really no examples of blockchain-based solutions being rolled out at commercial scale throughout the industry. But that's ultimately our goal, is to get to that industrial scale. And so there's two ingredients that we believe are necessary to actually achieve this. And that's developing a robust community of developers and users around a common platform, and then actually developing and delivering that platform itself. And so those are our two pillars of our work. Next slide, please. And this one also has an animation that will be 3 clicks, I believe. So we started, as I mentioned, in early 2017 with 10 energy corporates as our founding affiliates. But over the last 2 years, we've grown quite dramatically. And as of today, we've surpassed 100 affiliate companies, ranging from upstream resource companies to market operators to vertically integrated utilities. But you'll also notice a number of technology vendors in this mix, of hardware manufacturers. So it's a really diverse group with different needs, but are all focusing on digitalization, broadly speaking, throughout the energy system, and then joining together with us to understand how blockchain can complement or supplement those existing digital technologies. Go to next slide, please. And so now that we have a community, our goal is to align them around a common technology platform. So this is a survey that we did recently of our affiliates who are actively building applications on blockchain platforms, and we wanted to understand what technology they're actually using. And what we found is that there really is no common standard yet. We see some are using private or permissioned distributed ledger technologies. Others are using the public Ethereum chain, and others are building their own. And so what our goal is to deliver an open source and public technology that meets the requirements of these companies. And we are doing that by trying to understand why they've chosen these different technologies, understand the attributes that those technologies offer, and then build them into our platform. Next slide, please. And so the result of that is what we call the Energy Web chain. And you can think of the Energy Web blockchain as I guess, in effect, a competitor or an alternative to something like the Ethereum blockchain, which is a public smart contract platform. The Energy Web chain is similarly a standalone smart contract platform, but it has some distinct governance and technical features that are designed specifically for energy sector applications. And I'll touch on a few of those right now. So one is the Energy Web chain uses a proof of authority consensus mechanism, which means that unlike other public chains, which such as Ethereum that you may have read about, use something called proof of work, which is more decentralized, but also much more computationally and energy intensive. The Energy Web chain only allows vetted validators to actually create new blocks. And so some of the benefits of that are it greatly increases our throughput capacity. We have roughly 35 times the transaction capacity as public Ethereum. And it also drastically reduces the costs of running the network as well as the energy consumption. We estimate we're about 54,000 times more energy efficient than public Ethereum. The flip side of that is that it does intentionally trade some level of full decentralization, but we also believe this is appropriate because in the highly regulated and societally critical energy sector, we actually think that it's appropriate to have known and vetted validators authorizing transactions and creating blocks rather than fully anonymous and fully decentralized miners. Some of the other features that I'll just touch on very briefly include secrecy or data privacy. So this has been one of the real challenges to date with public blockchain approaches in the energy sector, that by default, all of the contents of every transaction are fully viewable by anybody in the network. And that's not practical for a number of reasons in the energy sector. And so we've rolled out a feature called private transactions and secret store, which allow parties on a public network to conduct transactions where the data associated with that transaction is only viewable by those two parties, but the outcome of the transaction can be verified on the public network. And there's a handful of other features that I'm sure Doug will touch on as he gets into the application piece, but that's ultimately our goal, is to deliver this blockchain infrastructure that can interact with physical devices such as generators or batteries or electric vehicles, perform foundational services then for energy blockchain applications that are developed by our affiliates, whether it's utilities or startups or others. So with that, Doug, I will turn it over to you to touch on some of the activity we're seeing with our affiliates and what to expect this year.
Great. Thank you, Sam. So I think as Sam indicated, part of our goal is to bring blockchain from being a boutique industry to one that's at industry scale. And to inform our approach around that, when we got started about 2 years ago, one of the very first things we did was work with our affiliates to identify what they believe would be the most valuable types of applications for blockchain in the energy sector. And some of the ones we identified are listed here, and it includes environmental attribute tracking. So in the U.S., renewable energy certificates or carbon offsets and their equivalents abroad, electric vehicle charging, virtual peer-to-peer trading, and demand response or virtual power plants. And these are ones where, in brief, a number of affiliates are either interested in one specifically or multiple. And to date, the way that we've been approaching this with our affiliates is to set up what we call pilots, where we essentially offer the various features, some of which Sam walked through on the prior slide, and put those in different bundles where we can test it for different business scenarios. And the area where we've done the most of this work is on environmental attribute tracking markets. And I go to the next slide to provide some more detail. Well, before I do, what I think is important about us, the approach that we're taking, is that by focusing on what our affiliates are most interested in and the areas where they find the most value, this is helping us, practically speaking, then determine what the most important requirements are for different applications that we're developing. As Sam alluded to, for example, with private transactions, this is something where we're looking at different approaches for how do you balance providing enough, with our goal being to increase the transparency and traceability of certain transactions people make. How do you then balance still the underlying data or the counterparty information, which of course people want to keep private. It's also really helped us focus on the importance of a secure Internet of Things integration, meaning with the slide that Sam walked through earlier, the interface between the physical world and the digital world to make sure we have secure and reliable data coming in. Because, as the saying goes, if you have bad data coming into a blockchain, then what's being transacted isn't good either. So this is another key priority area for us. And specifically at EWF, the Energy Web Link team, this is the team dedicated to looking at different options for collecting data from different types of scenarios. Well, I thought there was one other slide in here, but I'll just talk through some of the examples of our work to date and running things in the field. On the prior slide, there was a mention of environmental attribute systems, and to date, the area we've gotten the most traction is around this toolkit, as we call it, called Energy Web Origin. So the way to think about this is we're developing starter kits for people to build their own applications. So rather than EWF building an application that competes with, say, an existing renewable energy certificate tracking system, or building an application that competes with affiliates, we are positioning things where we help others develop applications that compete and innovate. And this is one of the areas we see EWF providing the most value, essentially accelerating the development of these applications. And to provide a concrete example of this, about a year ago, we did our very first test of Energy Web Origin, where we looked at unbundled renewable energy certificate transactions, meaning we collected data about actual renewable energy production, created digital assets associated with each kilowatt hour, and transacted those in a simulated environment where there was we did everything but financial transfer between the renewable energy producer and a corporate buyer. And we looked at that in a couple of countries, and to date we've run additional tests of this between France, Germany, Thailand, Singapore, Spain, the U.S. And I think what we're excited about is part of what we're developing allows for greater interoperability of systems to date that have operated in silos. What I mean by this is, on the prior slide you saw the example of electric vehicle charging, environmental attribute tracking. Why can't these things better talk to one another? In an example, in a recent test we put together in Germany, we actually we allowed for people when they plug in their electric vehicle to actually have green energy purchased automatically and get the proof on your electric vehicle application that you did in fact buy green energy. This is one example. I think we're also looking at with the German battery company, we're looking at tracking the full history of energy stored in a battery. And so the example here is people who have excess renewables capacity they stored overnight, but they want to sell the environmental attributes of that, allowing them to actually have the full history so they can trade the green attributes on the market after the energy is injected to the grid. But I'm happy to answer any specific questions about Origin. I know this is a very brief overview. The very last comment is it will probably be interesting to the group here. We're working with the PJM market, so we're looking over the next 9 months to essentially build a new tracking system for specifically starting with voluntary RECs. So the kinds of purchases that companies and cities make to prove that they're tracking toward renewable energy goals. And so over the next year, we're working with them to build something that can interoperate with the existing PJM GATS system for those who are familiar with it.
Okay, so thank you, Sam and Doug, and let's kick off the questions. Let me start. Sam, you mentioned at the front end that there's lots of hype about blockchain and energy, and the hype warranted?
I think I'm perhaps a little bit biased, but I think in the long term, yes. The fundamentals of the technology are really compelling, and if we think about the pace of innovation and development, the amount of talent and money that's being invested in this space, and to even use ourselves as an example, we have some of the world's largest companies that are actively investing and experimenting in this space. I do think that the technology itself has a really bright future. I think where the issue we see now is that there is a disconnect right now between expectations and reality. If you just Google blockchain and energy, you'll probably see everything ranging from fully decentralized peer-to-peer energy markets, and it's all going to be fully autonomous and wonderful self-sufficient energy utopia. That's just there's so much to kind of figure out before we get anywhere close to that. And the technology itself is still, as I mentioned before, really in its early stages. It's not quite ready for everyday use by all people in all facets of the energy sector. There's probably some work that needs to be done in terms of business model innovation. How do you think about monetizing software that's running on an open source and decentralized platform? There's some things with respect to usability. One of the issues for anybody who has ever experimented with using a blockchain platform, because there is no central administrator, something that seems really simple for everyday use in other applications is, resetting your password. There's nobody to reset your password if you lose your keys to your blockchain account. So, things like that to make it possible for folks to recover information if they lose it. There needs to be some development there. But again, to put things in perspective, Bitcoin's about a decade old, but Ethereum's only not even 4 years old. So it's still really early days, and I think we'll see quite a lot of activity and innovation here over the next few years.
Bob, just to add one quick comment, and just to, I think, tackle something that's in probably the background of people's minds. I think what we saw over the past year is people wanting, in terms of the amount of coverage and the types of people that maybe were offering different things, that there was a notion of getting rich quick, and I think we've gone through that part of the cycle. People wanting to raise money through, a vision that had nothing behind it, and they would use a token to help fundraise for it. I think we're past that point where people realize that's no longer going to work. But as Sam said, we're long term, we're very excited about the application of this, and specifically for the energy sector, given the number of changes that are happening in the industry.
I have a question about the amount of energy used. I believe one of you, I think it was Sam, talked about that you're talking about 54,000 times more energy efficient than, for example, Ethereum. I'm just wondering, how could that be?
Sure. So,
Sam, I can quickly start. I mean, in a nutshell, it's because of the different consensus model. So because we use what's called proof of authority rather than proof of work. With proof of work, you have people in a free-for-all race to solve a puzzle first, and so people want the most powerful computer that uses the most energy to solve the puzzle first. And with our system, because it's a known entity, randomly selected, they don't have to race others. They just have to solve it in a fixed amount of time. They can use more or less a generic business laptop rather than the kinds of computers that are now participating in Bitcoin markets, for example. But Sam, please add anything.
Yeah, I mean, I would just add, proof of work is so named because, as Doug mentioned, there's no gatekeeper. Anybody in the world, you, me, a company, you can go and download the software to become a miner, which is the term in proof of work networks for the nodes in the network that validate transactions and create blocks. And the way that you can verify the authenticity of a transaction and a new block is, as Doug said, solving an exceptionally difficult and arbitrary mathematical puzzle. And so there's this incentive to consistently add more computational resources. And so what we've seen is that the net result of this is that energy use, and really that's a proxy for computational power, it doesn't scale linearly. It's scaled exponentially as more people have joined the network to mine. And just to touch on why would somebody do that? Well, the miners who create blocks in a proof of work network are rewarded for their efforts by being allocated new tokens. So in Bitcoin case, it's Bitcoin. In Ethereum's case, it's Ether. And so there's this financial incentive to win that race and be the one who validates the most blocks. In practice, what we see is that mining nodes, no one computer will ever be powerful enough to ever win. So there are these things called mining pools, which are aggregations of many, many physical machines that act in a common, node network, essentially, to mine, to pool their resources together. So in proof of authority, right, we intentionally trade off this level of decentralization. It's not possible for just anybody to go download some software and become a validator in our network. You have to go through the process of being vetted by Energy Web Foundation, and there's also a cap for technical reasons on the number of validators that the network can have. But as Doug said, because we know who these entities are, they have a reputational stake, and there are some technical mechanisms to remove and kick out any nodes that misbehave. You can drastically simplify the mathematical puzzle that needs to be solved without sacrificing security or integrity, but you greatly increase the speed with which transactions can happen. And because you can run this software on something as simple as a laptop, you don't need these giant pools. So you not only use less energy on a per machine basis, but you scale linearly by adding only one machine for every node.
Thank you. This is my last question, then I'll open it up to others. Sam, Doug, I think Sam mentioned mitigating cybersecurity risk. I think in the article he referred to this as grid security risk. Could you talk just a minute or two about how that actually occurs? How does blockchain, or how can it mitigate cyber risk?
Sam, do you want to start with that and I can add an example?
Yeah, sure. So cybersecurity is such a broad term that I don't mean to imply that blockchain is some kind of panacea that's going to solve every cyber attack vector there is. But there are a few kind of specific attributes and specific instances where blockchain technologies can be an improvement over incumbent systems. So one is on recovery and persistence of logs. Some folks may be familiar with, there was an attack on Ukraine's power grid in, I believe, 2015, where the attackers were able to access the operational technologies used to actually control the physical components of the grid and brought down most of the country to the tune of a few 100,000 people, blacked out. And then they deleted all of the logs and audit trails of what they had actually done, which made it really difficult for the cyber response team responsible for restoring systems to normal operations to understand what had happened and how to reestablish systems. So there's been some really good work from Pacific Northwest National Labs that they did an analysis breaking down exactly how a blockchain-based system with a distributed record that is persistent and tamper-proof could have made it easier and faster to respond to that by preserving some of the logs and understanding what happened from a technical perspective. Some of the other instances is one of the more common attack vectors that we see today is phishing. So people, I'm sure everybody here, you get emails that purport to be from somebody you know. They want you to hand over some information about yourself or a password and, use pretty sophisticated social engineering to make it look real. In a blockchain-based system where you have, in a transaction, a sender can only send a transaction with by establishing and keeping a private key that can't be duplicated. You can have it doesn't necessarily solve the risk of what happens if you lose your private key, but it does make certain kinds of phishing really, really difficult, or if not impossible, because there's no way to forge a message from somebody in particular without that private key. And so you can think about applying that both to people, but also physical devices, and knowing that, say, the kilowatt hour reading that you're getting from that physical generator is in fact coming from that physical device. Doug, I don't know if you want to add anything to that also.
I mean, just one additional piece to add is, as people participate more and more in markets, especially, as you think about smart devices and so on, I think, and also seeing lots of the breaches not in the energy sector, but in things like Facebook, Twitter, et cetera, by offering a blockchain solution for how we store information about customers in energy sector in different utility networks, you make the exposure of customers less vulnerable to having their data exposed, because it becomes not one single point of failure, the ability to hack one database, but instead having to hack a more distributed system. So it just makes it more complicated to steal information about customers.
Thank you. Questions in the room here in Washington? Kat?
Doug, I just want to make sure that I heard you right. You track electrons through the PJM market from source to sink?
Sure. Just to repeat the question, it was to clarify whether we can track the electrons that are going from the original source to where they end up going. Is that correct? So the way we are approaching this is it's the same way that the short answer is no. We're looking at the actual green attributes that are in a single grid. So in brief, we're looking at you have X amount of kilowatt hours being produced by a specific wind turbine or solar panel, creating the equivalent number of digital attributes associated with that kilowatt hour number, and then making those available for purchase. So it's separate from the electricity themselves. Ultimately, we do see more and more opportunities, such as with power purchase agreements, of people buying the green attributes and the electricity together, but you're still not tracking the electron itself. You're sort of just, you're looking at the production data.
Other questions in the room here? Yes, Molly.
So the slide that you have for the history of computing, I read it right. There's discussion that for personalization and commodity. I'm wondering, from perspective, like what are the things that might slow the pace of process for talent? How do we essentially a whole new language have people have to get them from concept? How much is barrier?
Yeah, and just to repeat the question, it was referencing back to the slide about the history of computing, the transition toward being an early industry to one that becomes commoditized. What are the potential barriers to adoption of blockchain in terms of it becoming something that can scale up at an industrial way? And I'll take an initial stab at this, and then Sam, you may have some additional comments. I think for one, specific to the energy sector, one of the pieces that will keep adoption slower will be the extent to which we will be figuring out a scalable approach, which some of us are focusing on, but a scalable approach to bringing data from physical production and consumption assets so that they can be used on a blockchain. So it's on that image that we looked at earlier, the link between the bottom layer, the physical world, and the digital world. I think also you're right to say that your point about programming languages, that today the programming language being Solidity for Ethereum-based applications, one that not very many people know about. I think for one, there's a lot of people who are starting to get trained in this area. So looking at groups like Consensus that are training large numbers of people. But I think another point to make is that groups like EWF recognize this, and this is why, for example, we're opening up applications to more programming languages. And Sam, is there anything else you want to add to this point or this question?
Yeah, I mean, I would take maybe kind of a less technical approach to it. I do think one of the barriers currently is that for many incumbents, it's difficult to understand or think about how you monetize a decentralized and potentially open source solution. For companies that are accustomed to, making a lot of the revenue under the assumption of owning all of the data or of having full control over, a particular application or network, thinking about how they can pivot some of those business models, or in the case of startups, how they can outcompete incumbents in this world. So there's probably in some areas, that business model innovation piece. And then more than anything, in the energy sector in particular, it's such a technically complex and historically conservative industry that, and rightly so, when, as we say, if you're tasked with keeping the lights on, you're not about to take risks on something that's not proven. I think there need to be some real demonstrated proof points of how this technology is actually adding value to really kickstart adoption. Because, as I said, right now, a lot of what you see out there is hype, and we need to have some concrete, tangible proof points to point to say this is how it's being used, this is how it adds value relative to other technologies, this is why it's uniquely well suited to accomplish this goal, and that'll go a long way.
Thank you. Are there any questions for Sam and Doug from folks on the phone? If not, we're going to turn to the K&L Gates folks. And Buck, are you going to kick things off here?
Yeah, sure. I'd love to. Thanks
Thank
so
you.
much, Bob. All right. Well, good afternoon, guys. I'm Buck Endeman. I'm with K&L Gates. I have with me Danny Cohen here to my right and Ben to my left. We're going to talk a little bit about smart contracts and the energy regulatory landscape. Bob had a good question about, the hype of blockchain, and we all know when sort of hype meets highly regulated environments, lawyers get rich, right? So we're going to do our best to
Why are you smiling?
Well,
no, I'm kidding. Go ahead.
So we're going to do our best to sort of identify some of the issues that we've seen and some of the regulatory regimes which have held back probably the more speculative blockchain applications. And, Doug and Sam have a good product, and they laid out the ways that you can use blockchain to get more granular data to inform better decision-making that will potentially inform better policy-making. But let's take a look at the environment that these blockchain applications are operating in to make sure we all understand what people can and can't do and what the software enables and ultimately doesn't enable. And we're going to start that with a look at smart contracts, because smart contracts and blockchain and energy are often used in the same breath. And we have to understand what smart contracts are and what they aren't, because it's been my experience that when people start talking about smart contracts, web developers and blockchain enthusiasts will use smart contracts in a way which lawyers and other practitioners may be unfamiliar with. So smart contracts from a purely software development perspective, the top bullet definition really controls. It's a set of promises specified in digital form, protocols within which the parties perform on these promises. Really what that boils down to in plain English is it's a series of if-then statements. If a particular condition is satisfied, then some particular, the software executes on the code and you get a determinative result there. You have an automatic execution, you have a contract that's automatically enforceable. But then we get into the software developer meaning versus legal meaning. Boy, that sounds awfully simple, just a set of if-then statements. Well, only if it was only that easy, right? Because when we talk about the legal meanings of contracts, we talk about all those things we learned in first-year law school. You have offers. You have acceptance. Is there intent? Is there consideration? We all agree on the terms of the deal, or we just agree to something that is going to be absolutely meaningless. So when you hear the term smart contract, just know that it could be used to refer to simply a piece of automatically executable software code. And if something is going to be legally enforceable, the fact that you have a smart contract embedded in the blockchain or in some other type of software protocol doesn't necessarily mean it's going to be a legal contract, the outcome of which is going to be binding on parties. Next slide, please. So how do smart contracts relate to blockchain technology? Why am I starting off our little presentation talking about smart contracts? Well, particularly in the energy development and energy blockchain world, smart contracts are popular because they can sit alongside the blockchain code. And as Doug and Sam talked about, you have this immutable record of block on top of block on top of block. If a particular piece of information comes into the blockchain, a smart contract can trigger another transaction and add another block to that blockchain without the input, without the conscious influence of parties on either side of that blockchain. Your distributed ledger, your consensus mechanism will validate that smart contract like it would validate any other block on the blockchain, and you have a transaction that ultimately can't be reversed, can't be undone. And in many cases, like if you're settling tiny bits of electricity or you're trading renewable energy certificates in smaller amounts than your standard megawatt hour, that can be a great thing. It makes life a lot easier, it makes settlements a lot easier, and you can more people can realize value from that renewable energy ecosystem. But they are not obviously a one-size-fits-all solution that's going to usher in a new energy revolution. Let's go to the next slide, please. So a smart contract example, this is a pretty easy one, and the next two examples will actually highlight the pros and cons of what smart contracts are good at and what they aren't so good at. So here we have a pretty straightforward option in the PPA. Upon exercise of the option, the seller will deliver a particular quantity of energy, and the buyer will pay the strike price. Very easy to memorialize this in code. You set a strike price. You identify who the option buyer and seller is. You identify a quantity, and if the particular conditions are met, you can either tie this to an index or tie this to some other third-party reporting service. Then, boom, you have the energy delivered from A to B and the payment delivered from B to A. So very easy to do with a smart contract, and you can do that on a blockchain. Makes a lot of sense. Let's take a look at the limitations, Danny, on the next slide. And this is why, when people talk about smart contracts, I always tell them you can't get rid of your lawyers in every particular instance, because we have things, other contractual provisions that don't really lend themselves so easily to give that statement. Here's an excuse or a force majeure provision where there's something that is unanticipated by the parties. There's some event that we couldn't have foreseen at the start of the deal. Well, if that's the case, we're not going to spend a whole lot of time in the beginning of our contractual relationship looking around every single corner and trying to encode in software every possible excuse for performance breach under the contract. It's just going to be very difficult, and a lot of times it depends on subjective elements that are really only going to be defined at the point of the relationship when one party is looking to invoke the excuse or excuse performance. So here's just an example of a smart contract, which is probably better left to the traditional paper and contractual interpretation that we have now. When we step back and think about the types of contracts that smart contracts may replace, I always like to think of it like a traditional EEI or NASD or something like that, where you may have a master agreement which defines the relationship between parties, various avenues of recovery, sets out in broad terms the business relationship, and then obviously you have confirmations under those contracts, which are very, very straightforward on price and energy quantities. And, as we see the industry evolve, types of confirmation are very quick, short contracts, probably lend themselves better to smart contracts. People start to get more comfortable with them, get more comfortable transacting under smart contracts, and probably learning how to roll those smart contracts back when unanticipated things happen. Next slide here. So at this point, I'm going to turn this over to Danny. He's going to talk a little about the strengths and weaknesses of smart contracts, and Ben will finish this up with the broader energy regulatory scheme.
So teasing out on some of the characteristics that Buck touched on, I think one of the strongest characteristics of a smart contract is that it's self-executing, or in essence, you have an automated system. You program your smart contract to do a specific task that you want, and you know that when the relevant information necessary to trigger that task has occurred and has been uploaded to the blockchain, you're going to get that task. You don't have to worry about it. You don't have to check on it. It is going to happen. And going to point number 3, it's immutable. So a big strength of the smart contract is it can't be reversed. So again, between the two parties, you've agreed to a set of terms, you've agreed to a triggering condition. And once that condition has happened, your agreement is going to happen. You're not going to be concerned about, well, will my counterparty actually not go through the contract? Will I have to be concerned about that risk? At this point, there are no third parties that can intervene. And as we'll touch on in a second, that may also be one of the greater weaknesses of smart. But to the second point, decentralization, and Doug and Sam have touched on this. Smart contracts do not require an intermediary to run. They really just need a distributed series of computers if you're using mining, or a distributed group of individuals if you're using proof of authority, proof of stake. There's a variety of consensus mechanisms. But at the end of the day, two parties don't need to rely on someone like an escrow agent anymore. You don't need to rely on any specific third party, and that significantly reduces risk. It helps with the automation, and fundamentally helps with the legitimacy of the contract. So moving to the weaknesses. One, this requires knowledge of code, which as a lawyer, I have no knowledge of code, and that's why I went to law school. So this is really in the eye of the beholder, right? You're working with your engineering team. Yes, this is a challenge, but in some sense no different than any other challenge they would deal with in creating their architecture. But as Doug and Sam have talked about, blockchain is relatively new. Mistakes have been made. Ethereum, for example, is the most popular smart contract platform. About a year ago, over $100 million worth of Ether was lost because of bad code. And again, smart contracts are not reversible. So in order to get that money back, you have to go through a very complex negotiation with other folks involved with developing Ethereum to try to change the blockchain itself, which is another conversation we can have. But what's important to know here is if you're using smart contracts, you have to get the code right or no one will be happy. You will not get what you want at the end of the day, and you may not be able to recover it. Number two, they are inflexible, as Buck touched on. Smart contracts are very useful for very specific tasks that can be clearly encoded, clearly described, but for that reason, they also cannot be changed. So, for example, if you want to sell energy between two parties and you want a third party to hold on to the buyer's funds until the energy is transmitted, sure, you could write a very specific code saying, on this date, when this money is transferred, then the energy will go to the seller, to the buyer, and you can transact that with a smart contract. If you have something more complicated, it will be hard to encode and harder to change as conditions change and need a change in the contract. And folding into that third point is there is legal uncertainty. Contract law has been around for hundreds of years. Smart contracts have not. So understandably, courts have not really addressed this question. There's maybe one or two federal court cases on it. And even that, we're seeing that courts are just viewing blockchain in the same language, the same view as electronic contracts and the internet. So they're looking at things like click-through agreements. As we move forward and smart contracts become more widely adopted, maybe we'll see courts develop their own specific indicia for what constitutes, a legally enforceable contract. Or maybe we'll stay with how we view internet contracts, how we view electronic contracts. And more specifically on the enforcement point, again, as Buck had touched on, contract law is not going away. We're going to use the same principles, offer acceptance consideration. Is this a legal contract? Do the parties have the ability to consent? Is there mutual mistake? All the same things that we use in our normal practice. But again, because it's new technological advancement, because the characteristics are different, courts may or may not start adding new ways of interpreting it. And states have gone on board. There are several states that are very excited about this new technology. They want to promote innovation. They want to promote blockchain across a variety of industries. So they want to ensure that there is legal certainty to the use of private key technology, legal certainty to the use of blockchain itself as an electronic record, and finally legal certainty to the use of smart contracts specifically. To date, Arizona and Tennessee are the only states that legally recognize smart contracts specifically. And there are about 7 or 8 states, including Arizona, Ohio, Tennessee, that recognize recognize a private key signature as an electronic signature, and similarly recognize data recorded to a blockchain as an electronic record. And before I move on to Ben to talk about the industry applications and some of the, the hype, some of the more concrete applications to date, it's worth noting that there is some debate over whether or not these state initiatives are either duplicative of the e-Sign Act or the Uniform Electronic Transactions Act, or at worst, they're preemptive. And the fundamental issue being is these laws cover the same issues. Is an electronic signature, an electronic imprimatur count as indicia of consent? That question seems to be covered by the e-Sign Act, but to the extent you are a business in Ohio, Arizona, Tennessee, it may be worth looking into how those acts and those state laws interact. So with that, Ben?
Thanks, Danny. So it's the time in the presentation when the energy regulatory lawyer shows up and tells you all the things you can't do. Sam and Doug talked about some of the applications, we've highlighted them here as well, and some of the more near-term solutions that you may see. But really, when we started looking at this a few years ago, one of the things that jumped out is, how do you go about enabling business models against the backdrop of a century of utility and energy regulation that just not designed, for this type of system. And Sam alluded to that a little bit. So I just want to spend a few minutes talking about, our thoughts on this. In the article, we talk about this, and the goal was really to. Am I not on? Okay. Thank you. And the goal was really to just, tee up these issues just to get people thinking about them, rather than trying to solve them. So just thinking about some of the more novel applications of blockchain, and I'll talk about one in a second. We really identified two major hurdles to implementation, right? First is legal and regulatory roadblocks. The more transformative the application, really the more likely you are to run headlong into utility law and regulations. And then the second is, questions about whether proper incentives are in place. If you want to talk about utilities or other major players thinking about blockchain, thinking about technologies, are the incentives in place to get them moving? One thing that I think is important to think about is, this is really not specific to blockchain, right? Blockchain is a technology that can be used in connection with distributed energy resources or energy storage to sort of enable new business models. But some of these issues are sort of issues that with a broader implication. So just in the interest of time, I want to talk only about one model that has commanded a lot of attention, particularly in the past 2 years, and I'll just sort of highlight some of the regulatory challenges and hurdles. So how many of you have heard of the Brooklyn microgrid?
Lots of hands went up.
It's got a lot of press. But just as background, in 2017, LO3 Energy, which is a blockchain developer, announced Brooklyn microgrid project. The idea was to connect a number of homes in Brooklyn with smart meters, LO3's proprietary meters. Some have solar panels on roofs, some don't. And all of the energy consumption and production is tracked over the blockchain. And that the idea is that those with solar panels will sell the excess energy to their neighbors, right? There were a number of drivers, wake Hurricane Sandy, remote resiliency, remote green energy. And so the blockchain aspect of this is important. What it did was it allows you to take all this data, store it in a distributed ledger that everybody has access to, allowing for automatic payment settlement, smart contracts, and it's a secure system. So this is really the first, I don't know if it was technically the first, but it was the first major pilot to get significant attention in the press, sort of as a way to use blockchain to facilitate this new business model. So of course that got my regulatory mind going, because there are a number of issues. So I'm going to use it as a case study. I'm not trying to throw shade at the Brooklyn microgrid. It's an interesting project, but that's the target of my presentation. So energy and regulatory issues, right? So from an energy regulatory standpoint, if you think about what they're trying to do, which is sell energy from neighbor A to neighbor B without using it. So
can't hear you.
Is that better? Yeah? Sorry. I'll get closer. So if you think about what I was saying was the Brooklyn microgrid, what they're trying to do is sell energy from user A to user B without a utility. So you're dealing with a number of homeowners who are essentially acting as retail suppliers, right? They're selling directly to one another. Those are retail sales. So it's different fundamentally from net metering, where everything that's going on is going back to the utility, right? So in net metering, you're selling back to the utility. The utility takes that energy and sells it somewhere else. So this concept of sort of direct sales between neighbors, right? Can you even do this? So in New York, you have retail competition, right? So theoretically, yes, you could have all these different parties selling to one another. But in New York and in most states, you have to be registered as a supplier, right, to be able to do that. That's costly. There are various requirements. In some states, you can't actually own generation to be a retail supplier. And, there are a variety of compliance obligations and costs. So, there's a question of whether that even works if you have all these different homes. Is everybody going to go in and register? Probably not. And then you have a lot of states, the majority, in fact, that don't have retail competition, right? So in most states, you have the utility as the sole entity with the franchise to sell you electricity. So in those states, you read the laws, you're just flat out not allowed to do this, right? So the idea of direct peer-to-peer energy trading really doesn't fit today within the scheme in either retail choice states or in states without retail choice. And then another question is, how does consumer protection fit in? We joke about sort of the angry neighbor problem, which is what happens in this structure if you accept that you're going to have this microgrid. What happens if all of your neighbors don't like you, right? And they decide they don't want to sell you energy. How does that work? And then the second issue is, despite being labeled a microgrid, the Brooklyn microgrid leverages Con Ed's system, right? So they use Con Ed's wires, and participants rely on Con Ed to keep that system operating. So, when you talk about 2 blocks in Brooklyn, it's probably not that much of a concern, but if you think about sort of on the grand scale what people are trying to do here, and not all people, but there's been a lot of talk about sort of cutting the utility out. At scale, how would this work, right? If you do have a utility just acting in the middle to maintain the wires, how should they be compensated? Are there current incentives in place to allow for this? Should the utility be a wires-only platform? There are a number of questions. And then, more importantly, if you want to have the utility actually sitting in the middle to do this, do we have the proper incentives in place today to allow utilities to look at these technologies, such as blockchain, to enhance their systems in lieu of traditional poles and wires infrastructure? So, I think to the extent you want to get the utility involved in the conversation, looking at technologies like blockchain, that's something that you really have to think about. So, those are some of the things we looked at and we explore in greater detail in the article. So I'd like to, sort of in the interest of time, go to questions, but just a couple projections, right? So many of the things I just talked about, these hurdles, they're not blockchain specific, right? These are issues related to distributed energy resources, the changing grid, and they're things that FERC and state regulators are thinking about. They may not be thinking about blockchain's role, and I think that's an important conversation because I think blockchain can really facilitate integration of some of these technologies, but it's something that they're thinking about. I think that access to data and smart technology will also move things forward. As customers, we now have, think about Nest or these technologies where you can actually look at your phone and control your energy use. So customers are generally more aware of what's going on, and I think to the extent that customers are aware and have more interest, that will sort of push state regulators along. And then finally, I think the early blockchain applications that we'll see in the market, I think this is already happening, are those that don't reinvent the wheel, right? So I don't think that we'll be seeing the applications where they're going to cut the utility out in the near future, but something like the EWF pilot, the PJM, where you're really just taking an existing system and you're making it better, and you're not going to run into regulatory challenges. I think those would be the first ones.
And very quickly before we go to questions, for non-financial institutions, it's important to remember that how a digital token is used can have implications outside of the regulations you may be used to dealing with. Blockchains are very useful because you can digitize information and put it all in a token. That token represents a PPA, or it can represent money, or it can represent security. So how you use your digital token may implicate laws and trigger requirements that you don't actually want to, particularly in a peer-to-peer lending situation or peer-to-peer transaction situation. If you create your own digital token, that facilitates trading of energy contracts, you have to be careful how that's structured, how it's marketed. That could be security or it could not be. It could be money, in which case you may be a money transmitter. If you're an energy company, that's not what you want to be. So other things to think about in addition to the more traditional FERC and state energy regulation.
And just as an aside to close the loop on the Brooklyn microgrid, so they actually don't sell energy, right? They just transfer RECs. So as someone produces, the corresponding neighbor who buys is just buying a REC. And this has been something that they've struggled with because there are a lot of roadblocks. Despite what you may see in the news where the contention is that they're actually buying and selling.
Well, thank you. Let me kick things off on the question front. The first is about smart contracts. Doug and Sam indicated, I'm paraphrasing, that we're somewhat in the early days of the commercialization with respect to energy applications. It's more pilots and proof of concept and the like. How prevalent are the use of smart contracts in the energy industry, at least at this point?
Not that prevalent, I don't think. And you know, Doug and Sam may have a different perspective because they're actually responsible for rolling out a project right now in PJM. But in terms of the energy trading, like trading the actual commodity, I would say they're not all that prevalent, at least not on blockchain networks right now. I mean, I think we've seen, you know, options with various strike prices in the financial industry for years. But in terms of blockchain-based smart contracts, we see some people on the natural gas side developing a system for that. But in terms of live, actual commodity-based transactions, at least domestically, we haven't seen much adoption. Internationally, there's been some examples here in point two.
Can I add to that?
Sure.
So just to add to that, in terms of EWF's work on Energy Web Origin, you know, it's still at the piloting stage, but we, I think, are looking at things in terms of a smart contract in that, for example, if you're a corporate buyer, a company that says you're going to be 100% renewable energy or whatever it might be, we want to give these buyers more power to get exactly what they want because we recognize that corporate buyers in particular of any audience has very niche demands for the type of energy they're buying. And so we want to give these buyers who are driving renewable demand right now the ability to say, I want X amount of kilowatt hours of green energy this year or this week or this month. I want it to, you know, and then allow them to say, I want it to come from this particular state or country, you know, maybe from this particular type of renewable energy assets or from a very particular supplier if they have a long-term power purchase agreement in place with a particular supplier. You know, as much granularity as they want and allow them to then say, if the production data associated with my demand become available, transfer it to my account automatically. And so one of the first, you know, set of tests we looked at were, you know, in France, for example, Microsoft and Engie. Microsoft said, we want to buy 10 megawatt hours every day from Engie. And at the end of each day at midnight, 10 megawatt hours based on production, you know, Engie produced much more than 10 megawatt hours, but that then was transferred from Engie to Microsoft.
So it could help with the origin question? Is that what you're basically saying?
Well, I'm saying that's right now. I mean, I think we see it in much more sophisticated scenarios like demand response, you know, or other with electric vehicles where, you know, let's say, you know, power down your thermostat by X amount if a demand response event happens, where if the utility sends a signal out, demand response event power down by X amount, automatically responding, you know, that if this happens, then respond. And then maybe depending on the situation, the response could be one of multiple scenarios depending on what type of demand, how significant they need to power down. And then the follow-up would then be pay after the event is complete.
Got it. My next question has to do with the Brooklyn microgrid question. It seemed to me, and maybe the clarification that you had at the end makes a difference, that the regulatory issues you were talking about are more in the nature of the issues that arise because it's community microgrid, as contrasted with because blockchain technology is used for something, if not P2P, energy trading, you know, dealing with RECs. Am I getting that right?
Yeah, that's right. I mean, I sort of alluded to that in the beginning. I mean, blockchain is just a technology, right? It helps facilitate something like a community microgrid because you can have all the parties connected. You can have all these microtransactions executing in real time. You don't need someone in the middle. You don't need to like pay, you basically don't need like a PJM or someone to sit there and look at energy produced and energy consumed and do settlement and all that. It's all happening in real time, right? So it enables it. And so it's sort of pushed the conversation forward. But yeah, the issues are related to distributed energy resources and just the changing grid and how we're going to deal with that.
And if I may just add, just to be clear about where EWF sits in this space, from our perspective, one of the original reasons we got excited about blockchain technology was because we see the central position of utilities, albeit in a different form with different business models. But we think blockchain is an exciting and valuable technology specifically because it gives them greater ability to manage the more complex world that we're entering that Sam walked through earlier. It gives utilities more ability to manage the things that are behind the meter, the thermostats, the smart appliances, et cetera, and better manage the complexity of having neighborhoods where there's some production coming online, some response in terms of smart thermostats, and then electric vehicles who are storing electricity. And so I think for us, we recognize that there is some demand for people to go, and I'll use air quotes here, off grid, and I think that's in part due to a frustration of people wanting utilities to move toward more clean energy faster. And our goal is to help people, for example, in the case of Energy Web Origin, build tools to better indicate their demand for renewable energy and find people who can deliver that, but not necessarily remove the utility, just change the way utility does their business.
Thank you. Questions in the room in D.C.? Kat.
Couple questions. One, back to something that Dan, you said. You talked about how you went to have created a block. Can you elaborate on that? How would you have done, for example?
I think I heard my name, but I had trouble hearing the question.
We'll repeat it. Go ahead, Kat.
Just to finish out that point, if somebody moves, do you have to sell your blockchain key in order for them to participate? Do you have to redo the entire block?
Right.
I'm saying this wrong, but could you just elaborate?
Sure. So the question is, how do you undo a block if you have a transaction that was confirmed that you don't want to have confirmed? And then more broadly, I guess when parties move around, how do you ensure that you can keep contracting? More or less, right? And I'll take the first stab, and certainly Doug and Sam can jump in. But fundamentally, the way blockchains work is that when a block is confirmed, is then based upon all prior transactions. So the beauty is, for something to be legitimate, it has to refer back to something that happened in the past. And as you continue to add transactions, you add blocks to that chain, so you get a bigger and bigger block. The problem is, if you have a transaction that goes through that's either fraudulent or it was just a mistake, you have to start a new block. So you would take all the pre-existing data and you would start a new chain and go from there. And that is very difficult based on the type of consensus mechanism you have. So something like Bitcoin, where it's based on decentralized computers solving really difficult math problems, you would have to convince a majority, 51% or 50 plus 1, to all start mining a new block, or I guess in more English, just everyone to agree that the transaction that you did that was fraudulent or wrong, you want to pretend that didn't happen, go back to the transaction immediately before it, and start clean from there. And different consensus mechanisms are easier to change than others. And in terms of your question about using your private keys and transactions, as Doug and Sam have talked about, there's one private key for every digital wallet that you're using. So if you lose it, it's gone forever. But two, if somebody else has it, they can start transacting, and there would be no way to stop them unless we start a new blockchain. So in terms of parties contracting, you just have to be very, very clear about what digital infrastructure you're using, what private keys you're using, so people know who you're transacting with. But I'll let them speak to more specific strategies.
Dan, let's confirm it. But and Kat, your question might be like, say you move down the street maybe, and you want to make sure you're still able to maybe trade energy within that network. And your private key can be set up to be personalized to either yourself or an entity. Right. It's not necessarily tied to a particular physical piece of infrastructure, right?
Right. Yeah, it would be geographically based, for example.
Yeah, and just to add to that, I guess first on this last point, that's actually one of the benefits of blockchain in the sense of you have a single ID that's associated with the customer, whether that's a company account or a household account, and then the benefit is that you can then have an associated ID for all of the assets that are under you, all the the lights, the smart appliances, etc. That as these different devices do things, the utility say knows to pay you directly, and that, for example, if you have an electric vehicle, if you're charging up in one territory versus another, you have a single payment account. You don't have a separate payment account for the different companies that might own those charge points. But of course, still the issue is there's no password recovery right now. And would you please remind me of the first question, because I wanted to tackle that too, and I just forgot what it was. Your very first question?
The immutable block.
Oh, yeah. So a practical way that we, rather than having to take an approach where you move on a new agreement about a block, you go a different direction because you realize there was an error. A way we're practically addressing that is, let's say, for example, somebody wants to buy renewable energy RECs again. Same example I was talking about earlier. They wanted to buy X amount of RECs. Somebody transfers it to them, and they realize there was an error with production. That there actually wasn't that much production the day before that was transferred over, and there was a mistake. The way we're practically thinking about it is that you then issue a credit, where we say we owe you 2 RECs still. And what happens in this scenario is that, unlike today, errors always will happen, but this is a way to override and have a full transaction history that's documented, saying we bought 10, but it turned out that they only really transferred 8 to us. There's still 2. The next time 2 available, they'll transfer to us. That's fully auditable.
Now, do you mean that essentially you might have a block, like a wrong block, but it's then subsequently corrected by a credit block? You don't have to undo the block.
Not a new block, but it's just a new transaction that is documented in a future block. It's still the same. You don't have to go through the whole effort of going down a whole new set of blocks.
I think there's a distinction. Sorry, this is Sam. To jump in between. So in the example Doug's providing, the root cause of the error or the thing that you don't want to keep is that you had a faulty data input from the external world, not a fraudulent transaction per se that wasn't supposed to be possible in a block. So in that case, you can say, there wasn't that digital certificate that was issued yesterday is actually void. You can append some kind of tag to it to identify that particular digital certificate is no longer valid, and create a new one that supersedes it. The other kind of faulty transaction is where a miner or a validator has intentionally created a falsified block that should not be possible because it doesn't accurately reflect all of the preceding blocks. And in that case, then you do need to get that consensus to fork the network to revert to a prior state. But there's a subtle difference between those two.
We're winding down now. Any further questions, either folks in the room here in Washington or people on the phone? Last chance. So I'd like to encourage people who are in the room here and on the phone to read the Energy Law Journal. Also like to encourage you to consider writing an article for the Energy Law Journal. You can contact me, my email address here at Kirkland & Ellis, or Harvey Ryder, who's currently our executive editor, with your thoughts and ideas. I'd like to thank Kirkland for sponsoring this today, and very much like to thank the speakers, both in the room and remotely, for a tremendous presentation and for taking the time to write a great article. Thank you.